Alright, still on sort today, we're going to be taking a closer look at basic rules of multiplication and division of sort. Next, we'll go deeper into rationalization, which is a form of division of sort, rationalization of denominators, binomial sort, conjugate of binomials and their products, and rationalization of binomial sort. You're welcome, all dear viewers. Just sit back and enjoy the class. Alright, now we're going to be taking a closer look at basic rules in division and multiplication of sort. So the first rule is the multiplication rule. So when you have root m n, it's actually the same thing as saying root m multiplied by n, and which is the same thing as root m then multiplied by root n. I think we're familiar with that in our previous classes. The second one, when you're having something like root n multiplied by root n. So when you're having a root of a number multiplied by the root of the same number, it can also be expressed as this. Then you have it as n. So take note of that. Root n multiplied by root n will give n. So root a multiplied by root a will give a. So root of a value multiplied by root of the same value, the answer is that value. Okay, let's move on. We have the division rule. So if you're having root m divided by n, it can also be expressed as root m over root n, okay? And that is root m divided by root n. We are still saying the same thing, okay? These, and these are all the same thing, okay? Now, let's take some examples. We're going to be considering root 10 multiplied by root 15, 3 root 10 multiplied by 5 root 30, and long c, and this long d. So, solution. So we're going to be simplifying root 10 multiplied by root 15. We are splitting root 10 into root 2 multiplied by root 5. And we are going to be splitting root 15 into root 3 multiplied by root 5. Hope that is clear. Root 10 is split into root 2 multiplied by root 5. Then multiplied by root 15 is split into root 3 multiplied by root 5. If you have been following this series of teaching, then you will understand what I've been saying. So there is a lecture on sort for beginners. Check it in the description box below for you to understand better all this. Okay, so I'm having roots of the same kind. This is root 5 and this is also root 5. So what do I do to them? I bring the two root 5 together, connected by this line. So this is root 5 multiplied by root 5. I'm bringing the remaining roots, that's root 2 multiplied by root 3. Okay, so root 5 multiplied by root 5 is going to give me 5. Root 5 multiplied by root 5 is 5. Then multiplied by root 2 multiplied by root 3 will give root 6. So I can have my final answer to be 5 root 6. Alright, or I may decide to do it this way by saying root 10 multiplied by root 15, which is root 150. So like we're used to some set of numbers in previous class, so call them perfect square or perfect roots. So picking a factor of 150 among those numbers, if you can still remember those numbers, so 25 is part of those numbers, and 25 happen to be a factor of 150. 25 multiplied by 6 gives 150. So splitting this into 2, I will have 5 from 25 and I'll be having root 6. If you want to understand this better, check the link on sort for beginners. You will really understand. Okay, now the second example. So here I'm having 3 root 10 multiplied by 5 root 30. So how am I going to go about it? I'll first pick these 3 numbers that are not under root, the whole numbers that are not under roots. So that is 3 and 5. I'm going to connect them first. Okay, and that's going to be giving me 3 multiplied by 5. Next times I'm also going to be connecting the two numbers in roots, root 10 and root 30. Okay, so connecting the two numbers, I'm going to be having root 10 multiplied by root 30. So 3 multiplied by 5 gives 15, then multiplied by 10 multiplied by 30, that is 300. So I'm having root 300. So I can simplify 300 further. Okay, and I can simplify 300 into a product of 103. Why? 100 is a perfect square. 100 is going to be a very good number to use. Okay, so I'll be having 15 multiplied by 100 root 3. Okay, so that is 15, then multiply by, from 100 I'm going to be having 10, then root 3. To finish it all, I'm going to be connecting 10 and 15 again, like I did in this first step. I'm going to be connecting 15 and 10 again, so giving me 15 multiplied by 10, that is 150, then root 3. Why? If there's multiplication, I can multiply anything. Take note that if the sign here is addition or subtraction, you can match the two numbers together. If the sign here is an addition sign or subtraction sign, you can do anything further. The next example, C. I'm having root 3 plus root 2 into the bracket of root 3 plus root 27. How do we go about this? Okay, so I'm going to be writing out the root 3 here, which is one of the term here, and I'm also going to be writing out everything here in this blue. Alright, so I write root 3, then with everything in the second blue bracket. Okay, with that done, I'm going to be bringing out plus root 2, the remaining term in this bracket. I'm still writing out all the terms in this blue bracket. Okay, maybe I should explain that again. I'll be bringing out root 3, I'll be bringing out root 3, so writing out everything in this blue bracket. So with that done, I'll be writing out plus root 2, and I will also be writing everything out from this blue bracket. It's as simple as that. Alright, so let's simplify. Let's remove the brackets. How do we go about that? So I'll pick root 3 and root 3. Okay, so that's going to be root 3 multiplied by root 3. I want you to take cognizance of how I use my colors. Okay, so the product from the green line is giving a green answer. Okay, please take note of that. Then I'm also going to be connecting root 3 and root 27. So this is plus root 3 multiplied by root 27. Okay, with that done, coming to the second bracket, I'll be simplifying plus root 2 and root 3. So that is going to be plus root 2 multiplied by root 3. Then I will also be connecting plus root 2 multiplied by root 27. So that's going to be plus root 2 multiplied by root 27. I believe that is understood. It must be understood. At least with the use of the lines, it should be understood. All these connectors. Now, from root 3 multiplied by root 3, remember I'm going to get 3. From those basic rules, root 10 multiplied by root 10 is n. So root 3 multiplied by root 3 is going to be 3. Okay? Now, with that done, so here I'm having plus root 3 multiplied by root 27. So what's that going to be giving me? I'm going to be having plus root 3 multiplied by 3 root 3. Then multiply by, now this is 27. 27 translates to 3 root 3. Okay? From basic simplification, you will understand that plus root 2 multiplied by root 3 is giving root 6. Then coming down here, I'm having plus root 2 multiplied by root 27. Okay, so that is going to be plus 2 multiplied by 3 root 3. My root 27 is also translating to 3 root 3 here. Now let's go further. Okay, so here I'm having 3, still my 3 here. Now here I'm having root 3 multiplied by 3 root 3. So I'm going to be connecting the 2 root 3 for multiplication. Okay, how? Root 3 in black, they are identical roots. So from 3 root 3 I'm going to be having 3, and from my holy 3 I'm going to be also having another 3. You should understand that. So from 3 root 3 I'm going to be having 3, because root 3 multiplied by root 3 is going to be 3, and from my only 3 I'm also having another 3. So that is giving me plus 3 from the red 3 and 3 from root 3 multiplied by root 3. I believe that is understood. Then plus root 6. Okay, then plus what else again now? I want to connect root 2 and root 3. That's going to be giving me root 6. Okay, and plus root 3. So from root 2 and root 3 I'm getting root 6. Then from 3 here I'm getting 3. Let's move on. Alright, so here is going to be 3 plus 3 multiplied by 3, that is 9. So here I'm having plus root 6 plus 3 root 6. What is that? Here I'm having invisible 1 root 6, then plus 3 root 6. That is going to be 4 root 6. Okay, so from that 3 plus 9 gives 12, and here is plus 4 root 6. Okay, so what else can I do? I think I can factorize. There is a common factor of 4 here and here. So I can have 4 here. I can also have 4 here. So let me have 4 as a common factor, then open the brackets. So here I'm having 3, then plus root 6, closing the brackets. So what I just did here is factorization. The step from here to here is factorization. Alright, and this is my final answer. Next, 3 root 2 plus root 5 on in a bracket, open bracket, 3 root 2 minus root 5. Okay, now there is something special about this type of simplification that I will let us know later during the course of the class. Okay, so how do we do that? I'm bringing out 3 root 2 like it was done in the former example. 3 root 2, then write out everything in the black brackets. Then again bring out plus root 5. Then also write out everything in the black brackets. Okay, so it's as simple as that. So let's connect. Let's use our line connector. Okay, alright, so I'm going to be connecting 3 root 2 and 3 root 2 here. So that is 3 root 2 multiplied by 3 root 2. Okay, then connecting 3 root 2 and minus root 5. That's going to be giving me plus 3 root 2 multiplied by minus root 5. Okay, then coming in again, connecting plus root 5 and 3 root 2. So that's going to be giving me plus root 5 multiplied by 3 root 2 in green. And also connecting root 5, plus root 5 and minus root 5 here. So that's going to be giving me plus root 5 multiplied by minus root 5. Okay, don't worry, it's going to be understood. So let's pick it one by one. So here I want to connect 3 and 3. Okay, so 3 multiplied by 3 gives 9, and root 2 multiplied by root 2 gives 2. That is clear. Again, 3 multiplied by 3 gives 9. Now root 2 multiplied by root 2 gives 2. Okay, so we are done with this green. Now coming to this wine. Now we're going to be simplifying first the addition and the subtraction sign. So this is addition multiplied by subtraction. Okay, so that's going to be giving negative sign. Okay, so and this is a negative. Okay, then the next step is we'll pick plus 3 root 2 multiplied by root 5. Okay, so that's going to be 3 root 10. Okay, that's 3 root 10. So here we have plus root 5 multiplied by 3 root 2 plus 3 root 10. Okay, 3 here is there, then root 5 multiplied by root 2 is root 10. Okay, then the last one here is we're also going to be simplifying this addition and subtraction sign here like we did there. Okay, just the same process. So addition and subtraction sign, they are also going to be giving this negative sign bouncing in. Okay, so that is going to be negative, then root 5 multiplied by root 5, that is 5, just like I have it there. Okay, so I believe that is cleared. Now let's simplify out all that we have. So here is 9 multiplied by 2, it's going to be giving 18 minus 3 root 10 plus 3 root 10. Okay, so these are the same values but with different signs. So we have negative and positive but of the same value, so both are becoming 0. Okay, now we are left with what? We are left with minus 5. Okay, remember it is minus 3 root 10 and plus 3 root 10 that becomes 0. Okay, so everything from here is cancelled out for this negative sign. Then we are left with what? Negative 5. Okay, so minus this minus, then 5. Okay, so we are just left with 18 minus 5, and that's 13. That's the answer. I believe it's clear. Any question, just put it in the comment section. I'll be there to attend to your query. Alright, now moving on to the next stage, division of salt through rationalization. Okay, how do we rationalize? So let's take a look at these following examples. This is the first example, 24 divided by root 18. Now we have a denominator here that happens to be a salt. How do we simplify it? Now here b, we have root 54 divided by 3. Okay. Solution. Now, our root 18 is colored. Why? It's the denominator and it's a salt. How do we rationalize? Alright, this is how we rationalize. You repeat this, that is 24 over root 18. You repeat that, multiplied by, then you used root 18. Thus, this is how you rationalize. So that's going to be 24 root 18 multiplied by root 18 over root 18. You pick the denominator and you write the denominator all over itself. Okay, and that gives 24 root 18 divided by 18. I believe you understand how we get 18 here. That is root 18 multiplied by root 18. You have 18. And this is 24 multiplied by root 18. You have 24 root 18 in the numerator. So, and that further gives us 24 multiplied by 3 root 2. So from root 18 we have 3 root 2. Okay, and from there you have 72 root 2 then over 18. So let's simplify. Any common factor? Do we have any? Of course we do. 18 is a common factor between 18 and 72. So dividing by 18 we have 4 over 1. So that gives 4 root 2. I believe that is understood. Alright, let's move on to the next example, that is B. You understand better now in B. Right? Remember from our basic rule that root 54 over root 3 can also be rewritten as root 54 all over root 3. From our basic rule, remember that. So I'm actually writing the same thing but expressing them in different ways. So we have root 54 over root 3. Now, how do we rationalize? Then multiplied by root 3 over root 3. Just like we did in the previous example. The denominator was root 18. So we write the question, then multiply it by root 18 multiplied by root 18. Now here is going to be root 3 multiplied by root 3. Okay? Because root 3 is our denominator. Alright. So we have this to be root 54 multiplied by 3. Like we have it here. Then over root 3 multiplied by root 3 we will give 3. So splitting 54 into 2, 54 gives 27 multiplied by 2. Then root 3 still over 3. So I'm splitting everything out. This is root 27 multiplied by root 2 multiplied by root 3, then over 3. Okay, from root 27 I'm having 3 root 3 multiplied by root 2 multiplied by root 3, then over 3. Alright, so I'm having 3 and I'm having 3 here, so they can cancel each other. Okay, now for that I'm also having root 3 and root 3 here. I'm having root 3 and root 3, so that is going to be giving me what? 3. Okay, then root 2. Remember, we still have root 2 here. So we have nothing in the denominator again. And that is the essence of rationalization. Not just to have nothing in the denominator, but to express our denominator not in sort form. Okay? There is a reason for that. Your sort could be either positive or negative. Huh? Yeah. But you understand that better during quadratic equation or many other applications of sort.